All right, so today we will continue talking about sinusoidal modeling, and I want you to focus on the synthesis in this coming week. And so today's topic really is sinusoidal modeling, and we will improve the synthesis part. And so I only have 7 slides to show today, so it should be a kind of rather light introduction. And so let me just gradually get into my my slide. Anybody new join? Anyway, yeah. Okay, so a bit of a recap. So in the previous homework that you just turned in, you're given a baseline synthesizer. And so as we also, some of you have discovered and discussed on Tuesday, it has a few limitations. And for example, first, its number of peaks is fixed, right? So at first, you're prompted to answer to choose how many peaks you want to track, and that number is fixed throughout. Also, the baseline synthesizer sort the peaks according to their frequencies, and so peaks are also accordingly they're connected. Peak number 1 is connected to peak number 1 across the frame, lowest to lowest, highest to highest, and they are just connected in that order. So and last week I introduced to you that this is an equation that we use in the baseline synthesizer. So I remember one of you actually argued that the sorting is not a big deal. The only difference is how exactly the phase of each trajectory is going to be updated. And I suggested this frame-wise update, and you will increase the phase by the mean frequency, the previous frame, this frame, times, that's the mean frequency, right? Mean frequency times the duration, and that's a reasonable thing to do. So some of you argue that it's not that important, and argue that it is still maybe not as straightforward as you thought, but we can discuss on that. Anyway, so this is the frame-wise phase update, and to connect the peaks. The number of peaks is fixed. Also, peaks are first sorted, and the connection is also done accordingly. Might not be the perfect thing to do. So, so in this week, I want you to think about something else. You can, whether or not you can try something to improve this. Okay. So this week's objective is mainly to experiment with any ideas you can think about. You can come up with, explore them in doing the trajectory formation. Okay, I call it trajectory formation, which means that you connect the peaks to form a trajectory formation. And so once you have a trajectory formation idea, it happens in the trajectory domain, right? You still need to translate or to transform to synthesize the actual signal based on the trajectory. So that's another part, okay? So we want you to experiment first trajectory formation, as well as the corresponding synthesis strategies. Hopefully you will be able to create a more pleasant reconstruction of the signal. The more similar the reconstructed signal is to your original signal, the better, okay? So that's the idea. We want to create a more pleasant reconstruction to be to reduce the notable artifacts. You want to do better than the baseline synthesizer, right? So far, so good. Any question? Okay, so let's talk a bit about trajectory formation. Okay, so recall that last time in a quick overview of sinusoidal modeling, I presented this example. Okay, this example is a female voice, a singing voice, and you see vibrato in here. And so this is just to detect up to so many peaks every frame. And so I was telling you that naturally our eyes would pay attention to 5 long-lasting trajectories, and they appear to our eyes as trajectories. Then the idea is, then how do we teach our computer to do the same, right? So this is not, so this is the main thing for you to consider in this homework, okay? And so we observe that, and this is a result. This is actually a figure from my PhD thesis. And I hope we can agree that apparently the number of peaks, the number of concurrent trajectories, okay, is not fixed. I mean, at one time moment, maybe there will be this many trajectories, but the next moment trajectory, that number of trajectory might be different. Some trajectory can terminate. So in other words, if the number of trajectories is not a fixed number in this example, then that means that we need to somehow allow the trajectory to be born and die. So we talk about the birth and death of trajectories. And I list a reference right here, okay? So we'll look at the figure, a few figures from this reference. And this is a paper that's published by in the Lincoln Lab journal. Lincoln Lab belongs to MIT. And so this is an early work by two scholars at MIT. And so in this paper, they mention the birth and death of trajectories. Okay, so we'll be looking at the figures later. And so to show you that this is a reference I gave you. I have uploaded it to e-learning, and you'll find that actually in this paper, the two authors actually cited their own previous work that was published in a good journal, Actual Transaction of ASSP. Okay, and so 2 years before this kind of article. All right, so if you are really interested, I encourage you to find out, which I didn't, okay, to also find this paper out and see more details. Okay, so because this paper I attached to is mostly a sort of a review paper, okay? So a lot of details are missing. So you need to, if you want to really know the implementation details, you might need to refer to their earlier article that was published 2 years before this one, okay? Yeah, but the birth and death. So this means that birth means that the trajectory can start somewhere in time, okay? And it can end if it cannot be continued. Okay, so a trajectory can. So this really allows a lot of gives you a lot of flexibility as to synthesizing the sound. Okay, so so next, so this is the birth and death I was talking about. Okay, this is a direct copy from their paper, figure number 5. So let me go through the points first. Okay, there's a kind of a long list, and so I want that in this report that you're going to turn in next week. In this report and your code, still I will give you the basic points. Still 95% will be evaluated, judged by how well you can organize peaks into trajectories. Okay, trajectory formation. So that's the basic part of this homework. So to form trajectories, here are a few ideas for you to consider. Okay, first, if your tracking is a backward tracking strategies, that means that if you seek to connect peaks of this frame to existing peaks of the previous frame, so you're looking backward. Okay, this is backward tracking. So I can think that a reasonable strategy is for every peak to try to find the nearest neighbor, right? So for example, here, I'm not sure actually if this is backward tracking. Maybe it is, yeah. So for example, this peak, if we track it backward, the nearest neighbor is this one in terms of frequency, right? And this peak, the nearest neighbor might be this one, okay? So that's backward tracking. Finding the shortest link, finding the nearest, the peak in the previous frame that has the nearest frequency, okay? But after we do that for every new peaks in the current frame, we found that this peak in the next frame, in the previous frame, this one has to die because nobody chooses it, okay? None of the peaks chooses this peak to connect, right? So you cannot continue. So this is a depth we are talking about, right? Is that clear? I'd like to pause a bit. Is this clear? What is meant by the depth of a peak? Depth of a peak. All right, so that's so some peak might not be able to continue 对话. Okay, clear. Okay, thank you. All right, and the kind of the opposite situation is to resolve split, right? What if two of the peak simultaneously want to continue from this peak? It's totally possible, right? So, and then if that happens, who gets the priority? Which one of the peaks in the maybe the nearest neighbor? So then the kind of this connection, peak continuation can go backward and forward. You cannot let, in trajectory formation, the basic idea is that the trajectory does not contain any fork, right? 没有岔路, no fork, no forking, right? So you need to somehow resolve the splits, and to set a rule for who gets the priority for continuation, right? And a few other things to consider, including maybe you don't want the peak to jump too far. Let's say if somehow one peak that is really far away, high frequency, somehow you still get the right to connect. Do you want to forbid that? Do you want to prohibit that? Okay, and to prohibit jumps that are too large, because trajectory really is to imitate the way the human eyes, when we look at the distribution peaks, we automatically see trajectory. That's what our vision tells us. Okay, and so in that regard, maybe in your strategy, you might want to avoid large jumps in frequency. But how large is too large? Then it's up to you for discussion. How large is too large? Is one octave too far, or should you say half an octave, 半个八度 or 一个八度 octave, right? So this is really something. There's no right or wrong, not a kind of absolute answer for how large is too large. So this is kind of an art, and you can design your strategies for peak continuation, whether or not to prohibit large jumps. And also in the synthesis part, this might be easy, by the way. So a peak can start, a peak can terminate. A trajectory can start, a trajectory can terminate. And so once they start or terminate, you need to gradually ramp up or ramp down, right? And I think that should be quite straightforward to handle. We just set a virtual peak of amplitude 0, for example, and maybe this is not too complicated, right? Once you allow the trajectories to occur in any, you allow the trajectory to have a beginning point and ending point, then you might need to consider the corresponding strategies for handling the birth and death, okay? Right. And also the last point that kind of came to my mind is that, so now we talk about determining whether a trajectory needs to terminate or start. And it might be a kind of back and forth communication between the previous frame and this frame, right? The current frame, previous frame. So if that's the case, can your synthesis essentially be implemented in a blockwise, a frame-wise manner? Now we'll touch that later, okay? So because now you have been exposed to real-time processing or blockwise processing. It'd be super nice if sinusoidal modeling can also be implemented in that way. While those input signals are still coming in, we produce output. That'd be super great, okay? But somehow in the code that I gave you last week in your homework 5 starting code, it was not handled this way, right? So I think it'd be nice if some of you want to touch base on this issue. You can try to, after you determine all your strategies, maybe it would be a very nice addition to your report if you can discuss whether or not your synthesis algorithm can essentially be run in blockwise. I mean, not real time, I mean blockwise, okay? You can allow streaming input and streaming output. Yeah. Any questions so far? Any question?
no questions.
All right.
Perfectly.
Yeah, thank you. And now comes the bonus point, okay? In order to do this bonus part, you need to refer to the 1986 paper, right? So what's going on is that actually you don't need to read the entire paper, by the way, okay? I found that you need to focus around page 159, right? And also, sort of to answer Jonathan's request, do we have any reading material? I apologize, I should have given this paper to you last week. It will make your life easier, okay? But anyway, here's the paper, and you need to but I think this week, you need to only focus around page 159, 160, a few pages. The paper is longer, right? But then, let me introduce. So in this paper around 159, page 159, the author stated that the baseline synthesizer using 50% overlap window. That's what we are doing that last week in the baseline synthesizer. They claim that it works out fine. If the frame is relatively short at around 11 milliseconds, they found it should be working fine. So that's their comment. But they also said that, however, and in this, however, they cited their own work, the previous paper, that a better phase, first of all, the phase part, they argue that the better way for synthesis is interpolation, okay, not just superposing window signals. So I'm not sure if you remember that last week we talked about two different paradigms of synthesis, right? One is overlap window, the other is linear interpolation, right? So I argued last week that we don't need to focus on the linear interpolation, and I don't want to focus on that. It's a bit more tricky, and here's why it is trickier. Okay, suppose that you have a trajectory, you have recorded all the frequencies and amplitude of peaks, and you have managed to assign them into different trajectories. Okay, so and each trajectory would give you an amplitude, a sequence of amplitudes and a sequence of frequencies, right? And based on that, you can linearly interpolate the amplitude, that's fine. But for the phase, actually, as early as in 1986, these authors suggested that this should better be handled by cubic phase interpolation, right? So here, theta is the kind of instantaneous, the phase, the relative phase for this frame. Omega denotes the frequency, estimated frequency, and now we do that by quadratic interpolation fitting parabola. So this can be given by looking at the spectrum. But then how do you exactly figure out the coefficient alpha and beta so that your phase update for every sample, here n really denotes the samples, time samples, right, and integers, right? This could be challenging, yeah. So that's why I assigned this as a bonus part, only 5 points. If you really have done the rest of the trajectory formation, you've done that, nailed it, you can consider working on the bonus part, touching the synthesizer itself, right? So how do we determine the alpha and beta coefficients so that a phase is continued in the manner of cubic interpolation? And I want to mention that phase is tricky in that phase wraps around every 2 pi, right? So somehow you need to handle this situation, okay? So let's say if here the horizontal axis is frequency, so we are looking at the phase spectrum. Okay, phase spectrum for the current frame, phase spectrum for the next frame. And apparently we know that this gap must be 2 pi, right? Phase increment beyond pi, then it kind of reoccurs at minus pi, right? So that's the idea. But somehow, if you want to create a synthesizer to continue to kind of connect the phase from this phase to the next frame, should the phase in this example, should it be increasing or decreasing? That's the question. If you confine the phase to be between minus pi and pi, then this will be a decreasing phase envelope. But that might not be a good thing to do, because really, if you need to unwrap, the better idea is to unwrap the phase before cubic continuation, okay, before we perform cubic or any sort of phase continuation. So this could be tricky. I imagine this could be a tricky part. If you're super interested, you can try it. Okay. I haven't tried it myself even when I got my PhD, so it didn't bother. Didn't stop me from getting my PhD. Yeah, but by the way, my PhD dissertation is heavily uses sinusoidal modeling. Right, that's why this is one of my favorite topics. But anyway, I didn't do that. And so if you are super interested, you want to outperform my PhD thesis, please do this. Okay, I appreciate it. I really love to see if you want to work on this. All right. Any comment?
Quick question. So this bonus points 5%. If we successfully implement that, then we could get 100%?
Yeah. That's just similar to homework 4.1. Okay, some of you implemented 50% overlap and get above 95, 99. Actually, one person got 100. Yeah. I gave only 100 to only one person. Still, I need to look at your report. Did you give enough details of your implementation? How do I make sure that your implementation is correct, right? Is that clear enough? Yes, Alex?
Yes, that's perfectly clear. That makes sense.
All right, thanks. So any others, does anybody else have any comments? All right, so next slide. So, and kind of finally, once you have all the trajectories, please do take care of summing all of them. Okay, sum over, I mean, each trajectory would synthesize a signal like this. You consider, let's say, if we don't do the bonus part, that's fine, perfectly fine. We still consider 50% overlap window method. Then the window function need to be, at every frame, you need to consider the amplitude times cosine, the correct phase, how they update, and then according, also the frequency needs to vary according to the estimated frequency. Okay, so but then just remember, yeah, somehow one way or another you need to sum up over all trajectories. Okay, so this could be. I want to give you some freedom. Okay, so in your coding part, yeah, please consider what is please decide on your own what is the best way in terms of coding to achieve this summation over J. J stands for trajectory. Number one, number two, number three. Okay, and each trajectory has different length, for example. So for each trajectory J, maybe the length is, it can vary, right? Some trajectories are really short, some are really long, right? So how do we best handle that in terms of coding? I'll leave that to you. I think that could be also an interesting part. Any question here?
Nope, it seems clear.
All right. Okay, so I want to tell you that I want to assure with you that please feel free to reorganize the code completely, right? Now we allow the number of peaks to vary across frames, and you, in the end, you'll be summing over all trajectories, right? So you don't absolutely have to follow the kind of the data structure is really naive. Should I say the data structure sucks in the starting code I gave to you? So please don't feel obligated that you need to follow the structure. Okay, please feel free to completely reorganize your code. So in the starter code I gave you last week, for example, is first, the peaks are first all found, and then they're fed to the synthesizer. Okay, and you can still, you have the freedom to you know, 砍掉重练 to cut the tree and and you have a freedom to, you have all the freedom, right? That's all I want to emphasize. All right. So with that, that actually will conclude my introduction. So that's it. Let me just stop sharing. And any comment, questions?